Hello, this is FlippedHarber for Precalculus. In this video we'll be talking about section 5.6, sinusoidal graphs and sinusoidal curve fitting. The objectives for this lesson are to determine the amplitude and period of sinusoidal graphs, find an equation for a sinusoidal graph, determine the phase shift of a sinusoidal graph, graph sinusoidal functions, and find a sinusoidal function from data. Now our outline for this video, we'll be talking about what a sinusoidal graph is. What the heck is that? It's a fancy word. What does it mean? We'll be talking about the amplitude and period of those graphs. We'll talk about how to find an equation. We'll talk about phase shift, and then we'll be putting it all together into one big equation. Now, first of all, what the heck is a sinusoidal graph? Well, it's a graph that looks like the sine curve. So here we see three sinusoidal graphs. They have this up-down behavior, but one of them is very skinny. The blue one is very skinny. We get a lot of waves in there. The black one actually looks like it's probably just the sine of x or the sine of theta. The red one's been stretched out, but these are all sinusoidal graphs. They all have this wave look to them. Now, all of these waves could be a sine graph or a cosine graph, because we're going to look at changing these around. So part of it's going to be trying to decide, when do we want to make it a cosine, when do we want to make it a sine. I would definitely make all of these sines because they all start at the origin. Now remember, if you want to make it a cosine, there's this cute little equation that says that the sine of x is equal to the cosine of x minus pi over 2. That's a shift to the right. Remember that inside change idea from the last section. That's a shift to the right, pi over 2. So if it looks like a sine graph but we really want it to be a cosine, not that big of a deal. Now, again, like I said, I would probably make all of these functions sine since they all start at 0, 0. That's a good tip-off to go ahead and make it a sine. Now, first couple features of these sinusoidal graphs that we need to talk about are the amplitude and the period. Now, the amplitude is basically how tall the wave is. We'll take a look at a picture in a couple minutes. The period is going to be how long is that wave. You might have heard the term wavelength before. We use the term period in math because these aren't actually like water waves. These are just totally mathematical concepts to us. So the amplitude is that A that's in front of the sine or the cosine. The period comes from this weird Greek letter that's in there with the x. It's actually a lowercase omega. The period of a wave, t, we use capital T for period, is equal to 2 pi divided by that omega value. Now that's very important. You're going to want a knee-jerk reaction is to say, oh, the number in there with the x, that's my period. No, no, no. You've got to take 2 pi divided by that number to find your period. Okay, so here we see this generic sinusoidal graph. Okay, I know it's sinusoidal because it's just going up and down. The amplitude is how tall that wave is. Now notice, A does not go from the bottom of the wave to the top of the wave. The amplitude goes from the middle of the wave to the top, or the middle of the wave down to the bottom. If you draw it from the top to the bottom, that is 2 amplitudes big. The period is from one point on the curve to the very next point in the wave. So I drew it here from trough to trough. Those bottom things are called troughs. You want to make sure that you go from one point to the very next similar point. Don't try to draw this in the middle of the waves because people usually screw it up when they draw it in the middle. Draw the period, or think about the period at the top of the wave or at the bottom. Don't try to look at the middle of the wave when you're trying to figure out your period. And again, remember, the period is equal to 2 pi divided by omega. It's not that number with the x, it's 2 pi divided by that number. We're going to look at some examples, don't worry. So let's go ahead and find an equation. We're going to start by determining the amplitude of the wave. So that's like step 1, determine the amplitude of the wave. That's going to tell us what number goes in front of the sine or cosine. Then we want to determine the period t. Now omega is equal to 2 pi divided by t. So once you find your t value, once you find your period, 2 pi divided by the period gives us that omega value. Now, is it going to be sine or is it going to be cosine? That might be a big question. Do I want to make this a sine or do I want to make it a cosine function? Well, if it goes through the point 0, 0, make it a sine. If not, you probably want to make it a cosine. Now, I can't say, that's always the case to follow, but that's always a good rule of thumb. If it goes through the origin, make it a sine function. If it doesn't go through the origin, make it a cosine function. Alright, so here we have a wave. It goes through the origin, so you're probably thinking, oh, let's make that a sine. Very good. But let's work through the system. Amplitude is 2.5. Okay, that's from the middle of the wave, the x-axis, up to the top, or from the x-axis down to the bottom. That's 2.5 is our amplitude. Now our period is 4. Now how did I come up with 4? Well, the top of the first wave is at 1, is at x equals 1. The top of the next wave is at 5. So the period is that difference. So since our period is 4, that means that omega, the number that's going to go in with the x, is equal to pi over 2. Okay, so let's, again, since it goes through 0, 0, let's make it a sine function. Let's put it all together. 2.5 is our amplitude. Pi over 2 is our omega value. We got that from our period. So we put 2.5 sine of pi over 2x. Alright, so let's try one from our calculator. So this one's going to be a little bit harder to read. You got to realize, I made this so I know what it is, but I'll try to help you along what everything is equal to. First of all, our amplitude is 3. I went from the middle line to the top of the wave, or from the middle line down to the bottom of the wave. It's 3 units. You can just count that on the y-axis. Now our period is 2 pi thirds. 2/3 pi. Now how did I get that? Well, you've got to look at one point on the wave and then the very next point on the wave. This will be easier on the graphs that they give you in the book. Not so easy here on the calculator. But we plug that in to figure out our omega. Our omega value is 3. So the number starts at a negative. So that's a little bit weird. Our cosine always starts up above 0, 0. So this is actually going to be a negative cosine function. So it's a negative cosine function because it's starting down there at negative 3. If it started up at the top of a hill, I'd make it a positive cosine function. This one's a negative cosine function. Put it all together. Y equals negative 3 cosine 3x. Now let's talk about phase shift. The phase shift is simply a horizontal shift to the right. We always say that it's a horizontal shift to the right, so we're always subtracting the phase shift inside our parentheses. It's just common practice. Okay? If you wanted to shift it to the left, okay, fine. But it's generally a subtraction. It's a horizontal shift to the right. Now, basically we use this when the wave quote-unquote starts at a point other than the top, bottom, or the middle of a wave. Now what I mean by starts is if it's going through the y-axis, not at the middle of the wave, not at a crest, not at a trough. It's starting at some oddball thing. And you'll know them, you'll spot them right away when they're not quite right. That's when we use a horizontal shift. Now, this is what it looks like. Y equals a sine of omega x minus phi, like phi, phi, fo, fum. That's phi. And again, with a cosine omega x minus phi. So our phase shift can be found kind of there in the phi. But don't jump the gun here. Our actual phase shift is equal to phi divided by omega. Just like our period was 2 pi divided by omega, our phase shift is phi divided by omega. So be careful with that. Oh, I don't know why that's going on, but all right. Oh, well, we'll need to solve for that phi. That's weird. I got a whole lot of the same slide going on. Okay, so let's take a look. Here we have three graphs. Now the purple graph has no phase shift. The middle of the wave is where the y-axis is, so that would be a nice sine graph. The red one, well, it's not quite to the top of the wave when it goes through the y-axis, and the blue one, it's not quite the bottom of the wave when it goes through the y-axis. So those two have some phase shifts to take care of. Now, the red phase shift would be, I would just shift it that little bit to the right to get that to the hill. Okay, if you want to think about that. Basically, how far would I need to move the y-axis to the right to get to a nice point? So if I do a phase shift to the right, then I can think about that red curve as being a cosine function. If we look at the blue curve, and if I think about it as a sine function that's been shifted to the right, that would place the middle of that wave right at the y-axis. So our red wave has a phase shift that's a little larger than 1/2. Our blue wave has a phase shift of 1. Our red wave is going to be a cosine function. Our blue wave would be a sine function. Okay, so let's try to put it all together on this wave here. We've got an amplitude to deal with, we've got a period to deal with, and we've got a phase shift to deal with. Our amplitude is 2. From the middle of the wave up, it's 2 units. Our period is 4 pi over 6. Now again, how did I get that? Well, I don't exactly have 2 crests to talk about. I don't have 2 troughs to talk about. I've got one complete wave. And that wave starts at pi over 6 and it ends at 5 pi over 6. So our period is 4 pi over 6. Now yes, that'll reduce down to 2 pi thirds, which means that omega is equal to 3. Our phase shift is pi over 6. It's just been shifted a little bit over to the right. So that's equal to phi divided by omega. Omega is 3. We found that already. So that means that our phase shift is pi over 2. Don't forget to solve for that phi. Putting it all together, it's going to be a sine function because it's starting in the middle. 2 sine of 3x minus pi over 2. One last idea. I thought we were done. Vertical shift. Now, vertical shift should not be a big deal. It's just a plus or minus at the very end. Notice it's outside the parentheses. No omega to deal with, no omega to divide by. It just moves the graph up or down b units. It's a vertical shift. We've talked about transformations already, so this is not a big deal. Now, when this happens, the wave is no longer centered on the x-axis. It's going to be, maybe it's mostly above the x-axis, or it's mostly below, or it might be all of it be above the x-axis, or all of it is below the x-axis. That's when you've got a vertical shift, when it's no longer centered on the x-axis. Now, how do you find b? Big question. If we've got this new value to find, how do we find it? Well, we add our maximum value and our minimum value. I'm talking about the crest and the trough. Add those y values. Divide by 2, and you've got your b value. Basically what I'm doing is I'm finding the average here. So, take your maximum y value, take your minimum y value, add them up, divide by 2, and you've got your b value. Very, very easy to do. Alright, so it's time for you to try some of these on your own. I'll see you in class, and I'll see you online.